Hey guys, this is just a quick video explaining just a few reminders on how to complete the sections of this 4.1 to 4.2 quiz. So in the first section, you're supposed to label whether these are mutually exclusive or not mutually exclusive. So kind of the key thing to remember with this, if something is mutually exclusive, that means it cannot occur, so we would say simultaneously at the same time. Then it is, if it cannot occur at the same time, that is mutually exclusive. The other option would be not mutually exclusive. So not mutually exclusive means it can occur at the same time. Now these are a little bit confusing, but if, for example, we were to do number one, drawing an even numbered card and drawing a heart. So if you draw randomly one card, that's the experiment, you're going to draw a card out of a deck. Is it possible that that card could be both even and it could be a heart, right? So you think about, is that possible or not? Well, let's say you get a 6 of hearts. That would be an even and it would be a heart. So it is possible. It is possible, right? First one is possible. So then you think, is that mutually exclusive or not mutually exclusive? Well, that would be not mutually exclusive because they can occur at the same time. You can have a card that is both an even number and a heart. Right? So the next one, you would think if you take a test, is it possible to both pass the test and fail the test? If it's not possible, then it's mutually exclusive. If it is possible to both pass and fail, that would be not mutually exclusive. So I think you can probably figure that out. All right, number 5 through 8, we're given some stuff in English class. We have 9 AAD students, 6 auto students, 4 PES, and 3 DD-IM students. The teacher picks a student at random. What is the probability they pick a PES student? So this is pretty simple. You think about how many favorable over total. So it's like favorable outcomes over total outcomes. So if we're talking about PES students, how many PES students are there over the total number of students? So for the total, you just want to add these up. Total would just be 9 plus 6 plus 4 plus 3. So you just do the total number of PS over the total number of students in general. Number 6, probability of not a DD-IM student. And I think that's the wrong acronym. That's my bad. Anyhow, how many students are not DDM students? So all the other students over the total number of students. For number 8, you will need to do some multiplying on this. What's the probability that teacher picks 3? Basically, teacher's going to pick 3 students. You want to do the probability that the first is an AED. So probability of an AED student would be, well, there's 9 out of however many total. You figure that out. And then it's going to be times because it's an and probability. Remember, and is multiplying. So this, and then this, and then this. So the first probability, 9 over whatever, times. Next one is an auto student, so 6 over the total. Times, and I'll let you figure the last part out. For number 9, roll 6-sided dice. For these questions, I would make the chart that we made. You might make it in a couple different ways. Probability that you roll a sum of 3. So you want to do this little 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I would make this chart to help you. So if you get a 1 and a 1, that's a 2. You get a 1 and a 2, that's a 3. Maybe make this chart to help you with that. You might even have it already written out. 4, 5, 6, 7, right? You guys remember doing this? So that might help you for the sum. You also need to consider a couple other possibilities for like first number is even, second number 4. So in that case, you might, for the numbers 10 and 11, you might also want to make a little chart where you have still your 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All the possibilities. So this would be a 1 and a 1, a 1 and a 2, a 1 and a 3, 1 and a 4. Just do it this way, and then pick out 2 and a 1, 2 and a 2, 2 and a 3. So you're just going to go through after you got your whole chart finished. The probability that you get an even in the second number is a 4. So I would just look at all the places where the second number is a 4, which is actually going to be this column here, right? That's the only places where the second number is going to be a 4. And then look at how many times is the first number even. So we got even here, of an even here, here. So that would be, in this case, 3 out of the total number of possibilities, which is 36, 3 out of 36. And then you can figure out number 11 as well. For the next section, this is what we did in our last assignment, where we're using these conditional probability tables. So this is where you want to look at the given things. So the first one, it says, if a student is selected at random, what is the probability that they have a job given the student is a junior? So we start with this. So given this, the student is a junior, so you would want to just circle the junior column, row here, sorry. And then the probability that they have a job, well, there's 45 juniors that have jobs, and there's 66 total juniors. So 45 out of 66. So you'll do that. Most of these. 13 is not, there's no given part. If a student is selected at random, what's the probability that they do not have a job? So you just find all of the students that do not have jobs, 35 over the total this. Just pay attention to what there's a given part of that or not. We've got some different problems then, starting with number 16. It's kind of for these, this one is an OR probability. So remember with the OR, that's where you're going to be adding. But also remember that you have to, if there's a both, so the probability of either is this probability of A plus the probability of B minus the probability of both. So in this particular problem, strep throat is 0.2, flu is 0.15. Probability of both of them is 0.05. So you do first one plus the second one minus the third one. For 17 through 20, independent or dependent. So just think about if the second one depends on the first one. If it does depend on the first one, if it changes the outcome, that's dependent. If it doesn't, if they're completely separate, then they would be independent. So like, for example, the first one, you roll a die and get a 2. Then you spin a wheel and land on blue. Well, the roll on the first one doesn't have anything to do with how you spin. So these are independent because the first thing doesn't affect the second one at all. Right. So think about if there's any sort of implications from the first one that would affect the second one. And then we've got some cards questions. So for this, remember just some key things. There's 52 total cards. Basically, I mean, there's 4 of each number, right? So there's like 4 2s, 4 3s, 4 4s, 4 5s, 4 jacks, 4 queens, 4 kings, right? All that. So 4 of each number / face card or whatever. Remember, there's also 4 suits. There's 2 red suits, 2 black suits. So do your best on those. If we were to, maybe we'll do 23 together. It's a little bit challenging one. So let's set that up. This one is an OR. So this is the one where you have to think of probability of the first one plus the probability of the second one minus an overlap. So the probability of a heart or queen, the probability of a heart. Well, overall, think about how many hearts there are. There is 13 of each suit. So 13 in each suit. We'll write that. So there's 13 hearts out of 52 total cards. Plus, think about how many queens there are. Well, there's 4 total queens, so plus 4 out of 52. And then you got to minus any overlap. So think about, is there any cards that are both queens and hearts? And there is one, there is a queen of hearts. So then you would want to do that. The first two are a little easier than that. And then your last two questions, you are not replacing in your probability of doing like 3 consecutive things in a row. So these you are going to be multiplying in all of these. You're going to have to multiply 3 probabilities. But the key thing is here, it's without replacing. So that means you're going to pull a card out, and then your odds for the next one are going to change. So I'll have you set up the first one. Probability of 3 aces. Well, the probability of drawing 1 ace, well, there's 4 aces out of 52 total cards, times your second draw. So this is your first draw, second draw. Since you've already taken 1 ace out, you now have 3 aces left in 51 total cards, times, and then your third draw, think about how many aces would be left out of how many total cards. It's a similar concept for number 25. So, all right, that is a brief explanation, but as always, still do reach out to me if you need help.